Good morning, students. Now, Unit 2 has started now. I have already explained this. This is your syllabus: interpolation, polynomial approximation. This heading: interpolation and Lagrange's polynomial. First one: data approximation and Navier method. Derived differences: Hermite interpolation, cubic spline, spline interpolation, or spline interpolation. Very few topics are there in second unit. Now, already interpolation, I have already explained what is interpolation, right? Interpolation means the process of finding the original polynomial in between and given the range of x using the given data is called interpolation. That polynomial is called interpolating polynomial. Or in other words, you can say that the process of finding the function value with the help of given data within the range of x is called interpolation, right? What is extrapolation? Extrapolation is same thing, definition: the process of finding the function value with the help of given data outside the range of x is called extrapolation. Now, Lagrange's interpolation polynomial, right? Already I have explained this one. The board, there is 1.1 degree polynomial of degree 1 and polynomial of degree 2, like that. Here one simple example: determine the Lagrange's interpolation polynomial that passes through the point 2, 4 and 5, 1. Right? How many points are given to you? There are 2 points are given to you. Here this value is called, the first values are called x values and the second values are corresponding function values, or you can say y values. Here x0 is equal to 2, x1 is equal to 5. In general, the x values are denoted by x0, x1, x2 and so on xn, and the corresponding y values are denoted by y0, y1, y2 and so on yn. In other words, f of x0, f of x1, f of x2, f of x3 and so on f of xn. Here Lagrange's interpolating polynomial p of x or f of x is equal to, the standard notation is p of x. If you want, you can write f of x, right? Here the only 2 points are given to you. That's why you are using polynomial of degree 1. That is x minus x1 by x0 minus x1 into y0 plus x minus x0 by x1 minus x0 into y1. Here f of x or p of x is equal to, we know the values of x0, x1 and y0, y1. Simply we are substituting those values here. Now after simplification, we are getting a polynomial f of x or p of x is equal to minus x plus 6. Right? This is the polynomial which satisfies the given data. With the help of this polynomial, you can find the function value when x is equal, when x value is given. Suppose if x is equal to 2, what is the function value? F of 2 is equal to minus 2 plus 6, that is 4 only, right? Already at x is equal to 2, y value is 4. When x is equal to 5, y value is 1. If you want, you can cross x over here. Put x is equal to 5 here. F of 5 is equal to minus 5 plus 1 is 1. That means y0 value, y1 value is 1, right? Lagrange's interpolating polynomial of degree 2. Degree 2 means 3 x values are given to you, 3 5 values are given to you. P of x or f of x is equal to, this is the formula: x minus x1 into x minus x2 by x0 minus x1, x0 minus x2 into y0, x minus x0, x minus x2, x1 minus x0, x1 minus x2 into y1 plus x minus x0, x minus x1, x2 minus x0, x2 minus x1 into y2. This is the Lagrange's interpolation formula of degree 2, right? Similarly, can write in Lagrange's interpolation polynomial of degree 3. That means 4 x values are given to you. Okay. Now, see, use the numbers called nodes. Here the x values are also called nodes and term. Right, x0 is equal to, x1 is equal to 2.75, x2 is equal to 4. Find the second degree Lagrange's interpolating polynomial for f of x is equal to 1 by x. That means here, first of all, we are writing the given data, right? Given data is x0 is given, x1 is given, x2 is also given to you. F of x is equal to, here the function values are not given, but the function is given. That means using the x values, we have to find the corresponding function value. That means when x is equal to x0 is equal to, the given value is 2, f of 2 is 1 by 2, that is 0.5. Simply write 1 by 2 only. F of x1, what is x1? 2.75. F of 2.75 is equal to 1 by 2.75. If you simplify the sum, that is, you get 4 by 11. So how to get this? Means if you remove the point, by the numerator 100, right? 100 by 275. 25 4s and 25 11s are. You will get 4 by 11. F of x2 is equal to 4, 1. That is a 1 by x. Now f of x is given as 1 by x. Therefore 1 by 4. Here these are nothing but y0, y1, y2. Right? Three function values are given to you. Our aim is to find the Lagrange's interpolation polynomial of degree 2. Of degree 2 means you have to use this formula. Right? Now we know all the values. We are substituting and then simplifying this equation. We are getting this polynomial. P of x or f of x is equal to P of x or f of x is equal to 1 by 22 into x square minus 35 by 88 into x plus 49 by 44. This is the second degree polynomial. Right? అదే కదా అడిగింది మనల్ని. Find the second degree polynomial using Lagrange's interpolation. This is our required polynomial. An approximation. F of 3 is what actually? F of 3 is 1 by 3. ఎందుకని f of x is equal to 1 by x is given. F of 3 is equal to 1 by 3. If you simplify, or 0.33 అని వస్తుంది, or leave like that. If you use this polynomial, f of x or p of x తీసుకొని find out చేస్తే f of 3 or p of 3 is equal to, simply substitute those values, again you will get 0.329. Right? This is nothing but 1 by 3 only. Okay. Now here this is the practical problem. Now find the given function f of x. Let x0 is equal to x1 is equal to x2 is equal to, construct the interpolating polynomial of degree at most 1, at most 2, to approximate f of 0.45 and find the absolute error. There are two problems are there. In each case we have to find the interpolating polynomial of degree 1, of degree 2, and we have to find the absolute error. Right? For each one, for a bit. Now given values, first of all we are writing the given values. X0 is given, x1 is given, x2 is given. Here f of x is equal to cos x is given. Here the function values are not given to you directly. That means we have to find the function values. Now x0 is equal to 0. Here numbers ఇచ్చినప్పుడు radians లో కన్వర్ట్ చేసుకొని చేయాలి. f of x0 is equal to f of 0 is cos 0 is 0. x1 is equal to 0.6. Cos of 0.6 is equal to 0.82533. Similarly, x2 is equal to 0.09, f of x2 is equal to 0.9, cos of 0.9 is equal to 0.62160. If you want, you can write the 5th decimal, 6th decimal, 7th decimal places also. Right? Now, here I tabulated those values. That means we are expressing the given data in tabular form. X values and y values. These are called x0, x1, x2, and the corresponding function values are denoted by y0, y1, and y2, are denoted by f of x0, f of x1, f of x2. Lagrange's interpolating polynomial of degree 1, of degree at most 1, we have to write. Right. At most 1 means what we have to do? We have to consider only two values. We have to consider x0 and x1 only. Right? And based on these two values we have to find the polynomial. Now we wrote the polynomial. P of x is equal to, standard form is L0 of x, f of x0, plus L1 of x, f of x1. What is L0 of x? X minus x1 by x0 minus x1. F of x0 or y0 you can write. F of x1 or y1 you can write. Right? Now we are substituting those values. We got P of x is equal to this much. Right? It is a, here x power is 1. That means it is a first degree polynomial. Now after getting the polynomial, we have to find the absolute error. So what is absolute error means? Absolute error is nothing but exact value minus calculated value. What is exact value? The given original function is given. What is that? F of x is equal to cos x. F of 0.45 is equal to cos of 0.45. You have to find out. See, this is the exact value. What is the calculated value? Calculated value means by using Lagrange's interpolating polynomial, we have to calculate the function value at x is equal to 0.45. Put x is equal to 0.45 in this case. P of 0.45 is equal to 0.8690 something. Right? Now, what is the definition of absolute error? Absolute error is nothing but modulus of exact value minus calculated value. See, this is exact value minus calculated value. That difference is, absolute difference is called absolute error. Here the absolute error is 0.03144. Alright? So, next case is what? Interpolate, same bit. For the same bit, we have to find the Lagrange's interpolating polynomial of degree at most 2. At most 2 means, again we have to, here we have to consider 3 x values, right? Those are x0, x1, x2. Now based on those values we have to write the Lagrange's interpolation polynomial formula. This is the Lagrange's interpolation formula of degree at most 2. We know x0, x1, x2. Similarly, y0, y1, y2. Simply substitute those values here. After simplification, we are getting a second degree polynomial. See here, x square. A second degree polynomial in x, right? This is our required polynomial. Again, after getting the required polynomial, what we have to find out? Absolute error. Absolute error is what? Exact value minus calculated value. The difference, absolute difference of exact value minus calculated value. Now here, P of 0.45 you have to find out. P of 0.45 is, in the place of x you have to substitute 0.45, right? Now after simplification I am getting 0.89809, right? Absolute error is equal to exact value minus calculated value. No, exact value is f of 0.45 minus p of 0.45. After simplification we are getting 0.0023. This is absolute error, right? Now this is our first problem. Now try to solve this one. F of x is equal to ln of x plus 1. That means log to the base e of x plus 1. ln stands for log to the base e అనుకోండి మీరు, right, of x plus 1. Again here there are two cases are there. What the cases? First of all you have to find the Lagrange's interpolation polynomial of degree 1 and then absolute error. And in second case we have to find a Lagrange's interpolation polynomial or interpolating polynomial of degree at most 2, and by using that we have to find absolute error, right? Try to solve that problem. Second one, it's a practical problem, right? See, again we'll solve some more problems on Lagrange's interpolation polynomial, right? Everything is ready amma meeku. Just next rest of the syllabus emundi manaki. This is in our syllabus. Lagrange's after data approximation and Navier method is there, no? Divided difference is there, Hermite interpolation, cubic spline interpolation. Everything is ready. See, this Navier method, theorem, and their problems, right? Theorem and problem. Okay, next one more problem, one more application. Next one, Hermite interpolation polynomial, right? Corresponding data and problems. Divided differences, problems, applications, right? Cubic spline interpolation and their corresponding problems, corresponding applications, or you can say. See, every material is ready. The thing is daily one method చేద్దాం, but you have to practice this numerical analysis. ఈ క్యాలిక్యులేషన్ ఇస్ వెరీ పార్ట్ ఈజ్ వెరీ వెరీ ఇంపార్టెంట్. కొంచెం కేర్ఫుల్గా చేయండి, లేకపోతే మిస్టేక్స్ అవుతూ ఉంటాయి. ఫార్ములాస్ ఆర్ వెరీ ఈజీ టు రిమెంబర్, బట్ ద థింగ్ ఈజ్ ఓన్లీ ద థింగ్ ఈజ్ క్యాలిక్యులేషన్ పార్ట్, రైట్? సి, నేను ఆఫ్టర్ దిస్ మీరు ఆ ప్రాబ్లం, ప్రాక్టికల్ ప్రాబ్లం హోంవర్క్ చేసిన తర్వాత మళ్ళీ సమ్ మోర్ ప్రాబ్లమ్స్ చేద్దాం బేస్డ్ ఆన్ ఇంటర్పోలేషన్, అండ్ దెన్ విల్ మూవ్ టు దిస్ Navier మెథడ్. ఆల్రెడీ మెటీరియల్ ఉంది, నోట్స్ ఉంది. ఓన్లీ ద థింగ్ ఈజ్ యూ హ్యావ్ టు ప్రాక్టీస్. ఫ్రమ్ మండే అన్వర్డ్స్ ఐఎమ్ గోయింగ్ టు టేక్ ద క్లాసెస్, రైట్? ఈరోజు నాకు ఆఫీస్లో డ్యూటీ ఉంది, మన కాలేజ్ ఆఫీస్లో. ఇఫ్ పాసిబుల్ నేను రేపు సండే కూడా తీసుకుంటాను, లేదంటే మండే స్టార్ట్ చేస్తామమ్మా. ఓకే, రైట్. మీన్వెల్ ఈ నోట్స్ మాత్రం రాసేసుకోండి. నెంబర్ ఆఫ్ పేజెస్ ఎక్కువ ఉంటాయి, జాగ్రత్తగా నీట్గా కాపీ చేసుకోండి నోట్స్, న్యూమరికల్ అనాలసిస్, రైట్?